If you watched the 2010 World Cup, you remember the sound. A relentless, single-note drone that swallowed the entire tournament. But in 2026, the stadium experience will be different. FIFA has officially banned the Vuvuzela, burying it inside a 35-page stadium code of conduct. The object shifted from cultural mascot to prohibited contraband, policed alongside air horns and loudspeakers. This downfall had little to do with marketing failures or poor crowd control. The Vuvuzela's fate was sealed at its birth, locked in the exact second its physical injection mold was cut. The Vuvuzela began as a homemade tin trumpet in South African townships. In 2001, mass production began when a plastics factory worker successfully developed a new method for high-speed injection molding. This shift relied on industrial tooling. Once a steel mold is cut, the object's physical properties are frozen. The length, the bore, and the flare of the bell are all fixed within that metal block. This geometry dictates the acoustics. A single Vuvuzela produces 127 decibels at the bell. That is louder than a referee's whistle or a drum, a high but manageable product spec. The stadium reality, however, is a different scale. Tens of thousands of horns stacked together to create a 144 decibel acoustic anomaly. The resulting global backlash was swift and immediate. The Vuvuzela's drone presented a technical problem that television engineers simply could not filter out. Commentators were drowned out, and stadium announcements became impossible to hear over the broadcast. The television audience felt the impact directly. The BBC alone received over 500 formal complaints from viewers at home. FIFA had permitted the horn to celebrate local identity, but they quickly moved to ban it to protect their primary product, the broadcast. The horn's physical geometry was simply incompatible with the audio requirements of global television. Physical production offers an unforgiving lesson. Properties set in a tool cannot be patched like code. You can manufacture 1 million units, but you cannot make them quieter. The object's greatest commercial asset, its cheap, piercing resonance, was the same feature that made it a broadcast liability. This is the design trap. Decisions that determine success happen at the start, when changes are cheap, but consequences hard to see. By the time the broadcast and market react, the tooling is cut. The design is irreversible. Avoiding this requires design intelligence, the ability to simulate how a form will sound, sell, and age before a single piece of steel is cut. Mastering the concept phase defines the difference between a product that wins the world stage and one that is eventually erased from it.